Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, hari ini kita akan sambung with a new chapter, chapter number 3. What it is called? Electrochemistry. I think you already learned about this before in Form 5 or Form 4. Form 4. Okay, Form 4 electrochemistry. Kind of similar but with some difference sikit lah. Okay, sebab dia lagi detail. So with your prior knowledge on electrochemistry, it will help you to understand this better and faster lah, should be. Okay, so for this electrochemistry, we have 3 subtopics altogether. The first one is Voltaic cell, and then kita ada 3.2 Nernst equations. So basically, these 3.1 and 3.2 are closely related to one another. You know the applications of Voltaic cell, and then the Nernst equations is the applications of Voltaic cell. Okay, and then the 3.3, so kita akan belajar terus 3.1 and 3.2 for this lecture. And then for 3.3, it is called electrolytic cell. Electrolytic cell ni yang awak banyak belajar dulu, electrolysis. Kita buat electroplating. Voltaic cell ni saya rasa belajar sikit di waktu sekolah dulu. Okay, dua-dua pun penting. Okay, so this electrochemistry, last batch, the marks for exams were 7 marks. Okay, 7 marks. Kalau chapter 1, 10, chapter 2, 10, chapter 3, 7. Kenapa? Nanti saya akan bagi awak the whole ni balik lah. Cuma saya nak tekankan 7 markah adalah nombor yang besar. Sebab total up dalam paper 2 nanti 80 markah. Okay, 7 markah besar lah. So physical chemistry will contribute 27 over 80. Means 1/3 of all chapters yang kita akan belajar for this semester. Okay. Now, for introductions to chemistry, benda yang sama lah. Okay, we want to learn about electro comes from electricity. Chemistry comes from chemical reactions. So we have the interconventions between electricity and chemical reactions. So when we have chemical reactions, we want to generate electricity. We have the setup of Voltaic cell. Dari chemical reactions nak buat electricity. Chemical reactions, buat reaction, dia berlaku secara spontaneous. So sebab tu kita panggil spontaneous reactions because it happens naturally. Mesti ada benda lah untuk dia happens naturally tu. Okay, but then from electricity, we want to perform chemical reactions. We're going to use the setup of electrolytic cell. So for today's lecture, we're going to learn only on Voltaic cell. Okay, from chemical reactions to become electricity, they are spontaneous reactions. Okay, kalau electricity to chemical reactions, they are called non-spontaneous reactions. Dia tak boleh berlaku dengan sendirinya, dia perlukan external drive. External drive comes from let's say battery or any other power supply. Okay, so kita ada conversion. So kena faham ni dulu. Kalau tak nanti awak tak tahu belajar voltaic cell, belajar electrolytic cell, awak tak tahu kenapa kita nak tengok sebenarnya conversions of energy. Okay, so for this Voltaic cell topic development, we're going to first learn about the difference between electrode potential and also cell potential. When we say potential, it is the difference of energy. Energy kita nak guna dalam sekarang adalah dalam volt. You need to know these two terms. You need to distinguish between these two terms, electrode potential and cell potential. Lepas dah tahu beza antara electrode potential and cell potential, kita akan tengok the setup of Voltaic cell. Okay, the setup of Voltaic cell is not the same as in electrolytic cell. Okay, and then we are going to learn about the standard hydrogen electrode. Basically, this standard hydrogen electrode is the applications of this Voltaic cell. Tetapi this standard hydrogen electrode is used to find electrode potential. And then from all the Voltaic cell yang kita perform untuk cari electrode and cell potential, we are going to refer to this one table called standard reductions potential. Value-value dia ada positif, 0 to negative. Macam mana dapat di standard reduction potential? Basically, dia buat voltaic cell kat sini nak cari electrode and cell potential. Okay, SRP value is basically the combinations of all values kita cari untuk each potential, each electrode potential. Nanti kita tengoklah definition, awak faham benda apa saya cakap. And lastly, dah tahu semua benda baru boleh masuk calculations. Kita nak tengok what's the value between these two cells. Okay? Right. So first, kena clear dulu the definitions. So electrode potentials is basically you have this setup. Awak nampak ada berapa ni kita panggil electrolyte. Yang solution ni electrolyte.
Yang ni metal kita panggil electrode. Okay, electrode ada dua jenis, active and inactive. Inactive ni inert lah. Bila inert tak buat reaction. Contoh macam platinum, awak belajar dulu kat sekolah, platinum, palladium, benda tu tak react. Masuk dalam solution, dia tak buat reaction. But you also have active electrode like metals, zinc, copper, lead. Benda-benda tu bila dia aktif, dia pun bila dia bersentuh dengan solution, dia akan buat reaction lah. Okay, so we have this active electrode, let's say, dia tak semestinya aktif sahaja, inaktif pun boleh. Cuma saya nak tekankan, when you have one electrode and one electrolyte, this is what we call electrode potential. Bacaan untuk satu electrode sahaja. Okay, so this electrode potential is potential developed between n electrode, satu electrode dan juga n electrolyte. When they comes in contact, they will form potential difference between them. Electrolyte dengan electrode adalah dua benda yang berbeza. Satu solid, satu solution aqueous. Bila dia come in contact, dia buat reaction. Untuk satu electrode dan electrolyte, kita panggil dia electrode potential. Okay? Untuk satu dia sahaja. Then, how do we find this electrode potential? Untuk kita tahu tentang satu bacaan electrode potential, dia perlukan satu lagi untuk bagi bacaan yang sebetulnya. So, we are going to use this SHE. We're going to talk about this later on. SHE stands for Standard Hydrogen Electrode. Why do we use this SHE? We know zinc is an active electrode, is it? Dia aktif. Dia bukan inert, dia dekat group berapa? Dia block D kan? Transition element. Anything yang selain group 18, dia bukan kita panggil inert. Yang lain tu semua aktif. Bila dia aktif, dia akan bagi you bacaan. Sebab dia akan buat reactions, is it? They have the ability to perform chemical reactions. Okay, but then, in order for you to know specifically how much is this electrode potential is measured, kita kena gunakan satu reference value, iaitu SHE, hydrogen. Recall again, hydrogen, the most stable state is in solid, liquid or gaseous state? Gases. Awak rasa hydrogen, dia ada tak metal sendiri? Hydrogen boleh tak exist as metal? Tak boleh. So, sebab tu kita guna SHE sebab dia tak ada bacaan. Hydrogen dia tak ada bacaan, dia hanyalah gas kan, paling stabil. So, kita akan jadikan SHE ni sebagai reference. When we say reference value, they will have 0.00 volt. Okay. Baik, jadi kita akan tengok the setup of voltaic cell. You must have two electrodes. What kind of electrodes to be used in here? Dia mestilah guna inert electrode. Because we want to keep on the 0.00 volt, means we still need to use that electrode. But what kind of electrode? Tak boleh guna active electrode. Kena guna inert electrode supaya dia tak buat reaction to keep that 0.00 volt. Jadi kita akan discuss lah yang ni. Okay, boleh? Electrode potential untuk satu bacaan saja. Okay, then we have cell potential. Cell potential is the setup when you have both two electrodes and then you have these two electrolytes separately and then you have these, we call it as salt bridge, and then we have wire and stuff. Okay, this is basically the setup of voltaic cell. So from this voltaic cell, when you have two different electrodes, active electrodes supposedly, and then these two active electrodes, they have their own values. They have their own ability to perform chemical reactions. Jadi, bila ada dua value yang berbeza, dia akan create difference tak? Kalau tadi, contoh kita ada 1.1 untuk zinc, dekat oksigen SHE kosong. Ada difference tak? Tak ada. 1.1 tolak kosong dapat 1.1 je kan? Let's say we have zinc of 0.76, Cu 1.36. Do we have difference between them? Yeah, that's what we call cell potential between two active electrodes, two electrolytes and stuff. Tapi kalau awak tengok, dua-dua ni dia gunakan setup of voltaic cell. Bila cakap voltaic cell, dia perlu ada these components. The first one, they must have electrolytes. Two electrolytes separated. Two beakers. And then apart from electrolytes, they must have two electrodes. Dah ada electrodes, dah ada electrolyte. Macam mana dia nak buat reactions? Kenalah ada wire. Because when you have aqueous solutions, you have solid, we are going to perform redox reactions. Can I know what is meant by this redox reaction? Ada apa dalam tu? oxidations and reductions. One of these will perform oxidations, one of these will perform reductions. Okay, maksudnya bila oxidations, they will release or accept electrons. Release. So supposedly, yang release tu mestilah negative terminal. Kenapa negative terminal? Okay, tak apa. Katalah kita bergerak dari kiri ke kanan. Awak rasa siapa yang release electron? Zinc ke copper? Zinc. Okay, so because of this active electrode deep in its same electrolyte containing the same ions, they will create their own potential. We call it as apa tadi? Kalau sarung-sarung ni? Electrode ke cell potential? Electrode potential. This active electrode have the ability to attract or release electron on its own as long as they comes in contact with the solution. Kalau electrode seorang-seorang dia tak boleh release electron. When they comes in contact with solution, they will create potential. This potential yang kita nak tengok sama ada they have the ability to release or accept electrons. In a setup of voltaic cell, dalam any reactions, tak boleh dua-dua perform oxidations. Dia mesti balance each other. Satu release, satu accept sebab electricity will only happen when electrons are transferred. Satu transfer, satu accept. Okay, bila kita nak tahu siapa release, siapa accept electron, kita kena tentukan who's gonna be the negative terminal, who's gonna be the positive terminal. Assignment of positive and negative terminal in voltaic cell is a bit different from electrolytic cell. Because this is spontaneous reactions, what do you think about the terminal? Kita nak assign based on the ability of the electrode to perform reactions ke nak tengok kita ada bateri ke apa? Bila sebut spontaneous, tadi saya cakap dia buat sendiri kan? Dia yang create sendiri. Means kalau dia nak release electron, dia kena banyak ke sikit electron? Banyak. Mana kita nak tahu banyak tu? Sebab tu kena cari the electrode potential. Dari value electrode potential, kita akan ada positive or negative. By right, positive or negative, siapa yang ada banyak elektron? Negative. So, the one that releases electron will become the negative terminal. So, for this case, kita letak ni terminal dia negative. Sebab dia akan release electron. Yang copper ni, kita akan letak positive. Okay. So, apart from having wire, we also have this voltmeter. This voltmeter is used to only measure apa dia punya difference. Sebab kita nak cari potential kan. The potential difference is measured by voltmeter. Kalau sini 10, sini 2, dia punya difference bacaan kat sini 8. Macam tu, dalam volt lah. Okay, so tak apa Next one kita ada salt bridge. Salt bridge ni kenapa kita kena ada? They want to maintain the neutrality of the solution. What do we mean by this maintain neutrality of solution? Kita akan tengok sikit lah dia punya animation. So, zinc as negative terminal, they will releases electron. Bila releases electron, what kind of reactions will take place? Oxidations or reductions? Oxidation. So, zinc releases electron. Bila sampai kat copper, copper akan buat reaction apa? Reductions. Reductions sebab itulah daripada dalam electrolyte ni tadi, daripada dalam electrolyte tadi, dia akan bergerak ke sini untuk accept the electron. Dia tak boleh, dia bagi, dia tak buat apa-apa. Satu bagi, satu lagi have the kiranya ada stronger pull for electrons lah. Dia ada pull for electrons. Siapa yang terima, dia akan tarik elektron. So kita panggil stronger pull of electrons. Siapa yang memberi, dia ada weaker pull for electrons sebab tu dia bagi. Dia ada extra electron lah untuk bagi. So benda ni akan keep on happening. So what you will see is when you keep on performing these oxidation reaction, zinc 2+ akan jadi banyak dekat dalam electrolyte, betul tak? So they become highly positive. Bila Cu2+, dia pergi ke electrode, what will happen to your solution? Asalnya dia balance, positive negative dia balance. Bila positif banyak pergi ke electrode, what will happen to your solution? They become highly positive or highly negative? Highly negative. They will cause imbalance, right? Okay, that's why we need this salt bridge. Salt bridge is basically bridge containing salt. Bila sebut salt, must have positive, must have negative charge. Usually we use KCl and ACl. Dia tak buat reactions. Dia hanya berada di situ untuk maintainkan the solution punya charge. Tadi kita cakap when zinc keep on doing the oxidations, they will release zinc 2 plus ion into the solutions, right? And they become highly positive. When Cu2 plus keeps coming out from these electrolytes, the solutions will become highly negative. Bila highly positive, highly negative, reactions will immediately stop. They will only proceed with the reactions when they are stable, they are balanced. Balanced in terms of the neutrality of the solutions. So how are we going to maintain the neutrality of the solutions? By inserting this salt bridge into the two electrolytes. Memang bentuk dia macam U-shape tu. Okay, dia takkan keluar lah macam saya tunjuk ni. Bila awak tengok dalam ni, tadi kita keluarkan zinc 2 plus. So dia akan release 2 elektron. So Cl sekarang, satu je charge dia. Untuk balance kan, sepatutnya Cl kena masuk berapa dalam zinc 2 plus? 2. So, this Cl minus dia akan masuk dekat dalam awak punya electrolytes to balance the electrolyte balik. Tadi highly positive, kita kena top up negatif. Siapa negatif masuk? Cl minus. Okay. Lepas tu, kalau yang SO4 2 minus sekarang banyak SO4 2 minus negatif kan? Siapa yang akan masuk? K plus. Berapa banyak K plus yang patut masuk? 2. So, dan tu tadi sebab ada 2 zinc kan? Ni K plus dan juga K plus lah. Tapi kalau awak punya exam nanti dia tak tanya lah berapa banyak K plus nak masuk. No. Just ni adalah animations untuk faham how this voltaic cell works. Okay, in general, bila kita dah tahu tadi dia nak bergerak dari mana ke mana, okay, you must first, saya tak assign ke nanti sana. Okay, dia bergerak, so ini adalah negative terminal, this is positive terminal. Elektron bergerak, dia akan accept. At the same time, the salt bridge akan balancekan balik, pergi ke kiri, pergi ke kanan. Okay, what will happen, saya tunjuk balik. Bila dia dah bergerak, dia dah balance kan, awak tengok pada ni, zinc dan copper. One, dia akan slowly disappear sebab bila makin banyak zinc solid dia corrupt kat situ, dia akan jadi kecil. So kalau dia minta observations, awak kena cakap lah mass of electrode decreases. While for copper, dia makin bertambah kan, banyak deposited kan, mass of electrode increases. Sebab itulah dia makin kecil, makin besar. Tapi dia bukanlah habis semua. Okay. So from here, you need to know how to form the net equations, the balance equations, or other name, overall equations. The overall equations comes from reductions and also oxidations. So your oxidations will be performed by siapa? Zinc or copper? Zinc. So tulis, bila tulis macam ni, dalam example kita tulis macam ni. This worth 1 mark. Okay, oxidations happens from zinc solid to become zinc 2 plus aqueous and 2 electron. Experienced by copper, we have copper 2 plus aqueous plus 2 electron to form copper solid. So, kalau kita nak dapatkan net equations, kita kena buat apa? Discard siapa? Potong siapa? Potong the electron lah. Bila electron bertransfer, baru electricity berlaku. Jadi, kena cancel ke electron, make sure both oxidations and reductions got the same number of electrons, then only you can cancel them out. Sekarang ni, awak ada dua elektron. Let's say awak ada 1, 2 elektron, satu lagi 4 elektron. Kena buat apa? Kena darabkan 2 yang satu lagi tu. Dah back cancel kan, baru dah berdapat net equations. Bila sini tulis oxidation, reduction, net equation, awak pun kena tulis. Kalau awak terus tulis dia punya reaction, without mentioning who's gonna be the oxidations, who's gonna be the reductions, awak takkan dapat markah langsung. You don't even know what does this mean. When we have zinc to release electron, what does it mean? Kita tak faham dia oxidation ke, reductions ke. Okay, net equations pun kena tulis. Net equation dot apa? Together with the states of matter. Okay, so far? So, yang ni pula, selain you tahu how to perform the net equations, you also need to know because not all the time, chemists will use this diagram to explain about voltaic cell. Because we have journal, right? Journal tak ada gambar pun besar-besar sangat, dia banyak ayat. So, how do we represent this in terms of wording? Kita akan guna cell notations. Okay, cell notations is, kita boleh, is written from anode to cathode. So, who's your anode now? Zinc or copper? Side that will become the anode is the one that undergo oxidations. Oxidations adalah anode, reductions adalah cathode. Always, electrolytic cell pun sama. Oxidations always anode, reductions always cathode. Who's gonna be your anode? Zinc. So, kita akan start dengan zinc lah. Tidak, very well. Ni di bawah variation, so kita tahu anode to cathode. So zinc kita akan start dengan bila cell notations, you must first start and ends with an electrode. Electrode mesti dalam solid. Okay? Electrode mesti dalam solid. Kalau awak tak ada electrode start dengan N awak dalam cell notation, dia salah. Kenapa saya nak tekankan benda ni? Now you have both electrons. But in SHE, you have H2 kan? Nanti awak terlupa nak letak the platinum ke palladium. Okay? So kita start dengan zinc. Lepas zinc kiranya kan, dia punya pergerakan macam ni. Pergerakan dia start macam ni. Ni zinc kan? Lepas tu dia jumpa siapa? Lepas tu dia jumpa zinc 2 plus kan? Kena ada ni, kita panggil dia apa? Macam bila different states of matter kita letak satu palang. One bar. Tu bagi tahu dia adalah solid, masuk dekat aqueous. Okay, lepas tu kita ada zinc 2 plus. Lepas zinc 2 plus dia jumpa siapa? Salt bridge kan? Okay, salt bridge ni kita represent dia guna double bar macam ni. Salt bridge. Okay? Lepas salt bridge kita jumpa siapa? Masuk mana ni? Cu 2 plus together with aqueous. And then last kali kita stop sampai Cu solid. Okay. So bacaan dia kita faham lah. Bila you ada zinc, bar zinc 2 plus, kita tahu this zinc and zinc 2 plus belong to anode. Bila kita ada this double bar, ini adalah salt bridge that connects the two electrolytes. And then bila kita dip the salt bridge into the electrolyte, kita akan jumpa the solution of Cu2 plus. And then kita akan close the reactions with Cu solid. Okay. Itu cara kita nak buat cell notation. If you're given zinc 2 plus of 1 molar, then you need to include this as part of your cell notation. After aqueous, you put 1 molar macam tu. Kalau sini Cu2 plus aqueous, let's say 0.5 molar, you buat comma 0.5 molar dalam same bracket. Okay, so awak dah belajar nak buat net reaction. Lepas tu daripada anode to cathode kita akan form cell notation. Okay. Dan settle untuk setup of voltaic cell, dah tahu how it works. Okay, kalau dia minta operations of voltaic cell, kalau operations of voltaic cell, awak cerita lah, mula dia buat oxidation. Lepas tu dia bergerak, reaction bergerak, dia buat reduction. Lepas tu kita ada salt bridge kan, nak maintainkan neutrality of the solution. Macam tu lah. Okay, now standard hydrogen electrode is used to cari apa? Kita ada dua benda nak cari tadi, potential apa? Okay, when we have standard hydrogen electrode, we aim to find only electrode potential. The bacaan untuk satu potential sahaja, satu metal tu. So, you need to know, this standard hydrogen electrode is a half cell. Tadi kita ada half and half dapatlah satu voltaic cell kan? It's only a half cell that is prepared using inert electrode. Inert electrode can be either platinum or palladium. Okay? So, since it states here standard, dia mestilah ada standard condition. What is meant by this standard condition? In terms of pressure, berapa pressure dia? 1 atm. In terms of temperature, berapa temperature dia? 25 degrees C. In terms of molarity, apa molarity yang standard? 1 molar. So kena tahulah 1 molar aqueous solution, 1 atm hydrogen gas, 298 Kelvin. Kena tahu benda ni sebab tak tahu yang ni nanti ada masalah dekat Nernst equation. Nernst equation. Okay, these are all standard conditions. Whenever we have standard, for any calculation ada not atas tu. Not. Yang O atas tu. Okay. So, the electrode potential untuk standard hydrogen electrode ataupun kadang-kadang kan dia tak bagi standard hydrogen electrode, the still hydrogen electrode, the value is 0. 0 volt. Bila tak bagi tahu standard hydrogen electrode, it might be the temperature or molarity is not 1 or 298 Kelvin. Itu sahaja beza dia. But the value of potential electrode is still 0 volt. Okay. So, macam mana kita nak guna electrode potential ni, kita nak guna SHE ni? Dia adalah half cell. Dalam setup of voltaic cell, kita ada dua half cell, right? One undergo oxidation, one undergo reduction.
When you are given SHE, you know already the value is 0. Okay. So macam mana kita nak tahu kalau in experiment, nanti awak akan buat eksperimen ni dalam experiment 3. Okay, experiment 3, kita akan tengok bacaan dia berapa. So awak nak tahukan dia electrode potential. Kalau dia bagi negative value, nanti kita akan masuk formula. Formula tu yang tentukan dia ni adalah anode or cathode. Okay. Right. So now let's say we have zinc. And we know already zinc tadi dia banyak elektron, right? Banyak, kita tak tahu lagi bacaan dia ni, dia banyak elektron ke? So bila kita pair up this zinc and in zinc 2 plus with the SHE with platinum in the acid solution, awak akan dapat, dia akan buat macam ni, zinc bagi 2 elektron. Hidrogen ni satu charge dia kan? So kita nak pair up dengan 2 elektron, ada berapa hydrogen plus yang kena pergi buat reaction? 2. So these 2 hydrogen plus akan pair up jadilah H2. Bila H2 maksudnya dia akan form H2 gas, right? So should have bubbling of gases kalau kita buat reaction. Okay. Lepas tu, apa yang berlaku? Tadi zinc masuk, zinc 2 plus banyak kan? Jadi, apa saltfish akan buat? Masukkan siapa? K ke Cl? Cl minus kita akan masuk 2 lah nak balancekan zinc 2 plus. H tadi daripada H plus, dia dah pergi kan? Dekat platinum. Dia tak buat reaction dengan platinum, dia just pergi dekat platinum. Platinum ni inert. So bila H plus dah pergi ke platinum, what will happen to your solution? They will become highly positive or highly negative. So kita assume highly negative lah. Faham tak? Okay. Lepas tu, apa yang kita kena buat, kena balancekan balik. K plus akan try to balance balik the solution. Itu yang dia buat lah. Okay. So daripada reaction ni, kita akan dapat bacaan nanti. We know SHE is 0.00 volt. And then, zinc kita tak tahu lagi, tapi bacaan on the voltmeter, kita ada positive 0.76 volt. This is not the electrode potential of zinc. Because we want to find the zinc punya electrode potential. So we know this is the bacaan on the voltmeter. We know already hydrogen SHE got 0.00 volt. Then we want to find this E naught of zinc plus against zinc. So how do we find this electrode potential? We're going to rely on this formula of E naught cell equal to E naught cathode minus E naught anode. Only this formula, tolong pegang pada formula ni walaupun dalam notes awak ada lebih pada satu formula. Saya tak nak awak guna yang oxidation reduction tu. Saya nak awak guna cathode dengan anode itu saja. Okay? E naught cell equal to E naught cathode minus E naught anode. This E naught cell is standard cell potential. The cell potential comes from Voltaic cell and they happen at standard conditions of 298 Kelvin, 1 atm and 1 molar of solution. Okay, boleh So tadi kita tahu E naught cell kita dah ada bacaan belum? Ni, dah ada bacaan belum E naught cell? Dah, so substitute sahaja value kita. Okay, E naught cell kita adalah this value. Berapa dah? E naught cell kita 0.76. So kita tahu H plus kita akan jadi cathode. Sebab apa? Sebab yang kelihatan dia adalah zinc. Okay, jadi kita susun cathode kita hydrogen SHE. Kita punya anode adalah zinc. So awak tahu hydrogen got 0.00 volt. So we want to find this zinc. So simply rearrange the formula sahaja. Zinc bawa ke sana jadi positif kan? 0.76 dari positif langkah sama dengan jadi negatif. So you will have electrode potential of zinc equal to negative 0.76 volt. How do we know whether this value is correct? We already have it in the standard reduction potential. This is the standard reduction potential table yang saya cakap tadi. Memang value dia. Kalau awak tengok zinc 2 plus ada good reaction negative 0.76. So betul lah apa reaction kita buat ni. Okay. Okay, nanti awak tanya pula, ni anode kan undergo oxidation. Kenapa dekat sini dia punya reaction adalah reduction? Okay, bila dia nak masuk table, dia kena standardizkan the reaction somehow. But then, awak tengok walaupun dia oxidation sini, tapi value dia indicates they got more electrons. So more electrons should be oxidation or reduction? Reduction. So, walaupun sini semua dia standardized reduction, but then the value yang indicates dia undergo reduction ke oxidation. Okay. Kalau more positive maksudnya dia kurang elektron, dia sepatutnya accept kan. Dia lagi akan prefer oxidation, reduction. Kalau yang lagi negatif ni, dia akan prefer oxidation. But not all the time, positive akan jadi cathode or negative akan jadi anode. Sometimes you have two different combinations, active electrode with negative value. So kita akan tengok who's got more positive value. Bila more positive, they will become the cathode. Macam itulah. Dia bukan selalunya positif, negatif. Sometimes dua-dua negatif. Okay, salah satu tu mesti lebih positif untuk jadi cathode. To undergo reduction. Okay. Okay. So tadi kita buat untuk cathode anode. Now kita buat untuk, kita try untuk dapatkan dia punya cell notation. So zinc undergo reaction to release electron, get zinc 2+. And then reduction. Reduction kita start dengan H+ kan. H+ dia akan accept elektron. Tapi sebab kita nak balancekan dua elektron kat sini, that's why we canted by 2. 2H+ plus 2 elektron. Or dapat H2 gas. Okay, lepas tu kita nak buat net equations, kena cancelkan the electron. Then you will get our net equations of this. Okay, now, do you have any electrode on your reduction reaction? Ada tak electrode kat sini? Electrode must be in solid state. Ada tak electrode? Tak ada. Tapi kalau nak buat cell notation, kena ada kan? Siapa kita punya electrode dalam SHE? Platinum. Okay, jadi bila platinum, in your cell notation, even though in your reduction reactions you got no platinum, you have to include it as part of your cell notation. If not, your cell notation takkan dapat jawapan yang betul. Okay? So kita start. How do you start your cell notation? Kita start anode tu. Kata, who's your anode now? Zinc. So kita start dengan zinc solid. Lepas zinc solid, dia akan masuk electrolyte kan? Dia pun apa? Zinc 2+. Kita ada satu bond. Lalu kita ada different state. And then, lepas zinc 2+, kita akan lalu salt bridge macam mana kita lukis? Double bond. So we have this double bond indicates this is salt bridge. And then, lepas salt bridge masuk solution kan? Electrolyte awak siapa tadi? H+. Okay, note that we already have this 1 molar. Sebab tadi dah mention dalam Voltaic tadi. Kita ada 1 molar. So kena include lah macam ni. And then lepas H+, dia pergi mana? Dia jadi apa dulu? H+, dia jadi H2 kan? So dia jadi H2 gas dulu, 1 atm. Kalau gas, kita letak pressure dia. 1 atm. Lastly, boleh tak kita stop macam ni je? Belum jumpa balik. Kita mesti ada something yang kita rely on untuk accept the electron, right? Must be the electron. Who's your electron now? Platinum in solid state. Okay. Nah, tadi kita check anode, zinc banyak elektron. Now kita nak check pula copper. Copper tadi yang kita tunjuk awal tadi, we have it on your cathode side, right? Because they tend to accept electron because they got stronger pull for electron. Jadi kita letak pula, sebenarnya tak kisah pun nak letak kanan ke kiri. Tapi saya suka bila yang release electron on the left. The negative terminal on the left. Opposite salah. Lepas tu saya keep on letak negatif kiri, positif kanan. Tak pergerakan awak senang. Awak ingat satu flow je. Kiri ke kanan. Oxidation to reduction. Anode to cathode. Okay. So now kita akan placekan SHE belah kiri. Cara lukis dia macam ni Kena ada this macam kita panggil this container. Tapi ada ruang kat sini sebab kita nak insert gas. Because we know this platinum won't do any reaction, right? Dia akan jadi perantara sahaja. Dia tolong sampaikan. Apa yang kita nak sampaikan? Kita nak sampaikan hydrogen gas. Masuk dalam ni, hydrogen gas sampai ke bawah ni. Dia buatlah, dia accept lah electron and what not. Okay? So the hydrogen gas must be 1 atm and make sure sini ada ruang. Kenapa ada ruang? Sebab dia kan nak interact dengan your electrolyte. Kalau bekas tu tertutup, macam mana dia nak masuk? Kan? So lukisan ni kena properly adjust lah. Okay? So H+, 1 molar, platinum electron. Okay, now, we expect the hydrogen SHE to undergo oxidation. So bila undergo oxidation, electron will be on your right hand side or left hand side dalam reaction. Nak release electron. Electron to be released kan? So we must first start with H+ or H2 gas. you want to release electron on this side. You know you are going to form either H plus or H2. You want to release electron now. You should start from H2. Maksudnya, dia punya reaction ni, pergerakan dia masuk, dia try to masuk. Lepas tu dia ni tangkap. Lepas tu dia gerakkan elektron. Macam tu. Okay. Okay, so H2 kita insert dekat dalam this setup. Lepas tu dia akan releases electron. So, dia akan releases electron and captured by the Cu2 plus on the other side. Okay, lepas tu tadi kita releasekan 2 hydrogen. Ni kita akan balancekan dengan berapa Cl? 2 Cl akan masuk to maintain the neutrality of the solution. And same goes to K plus. Tadi Cu2 plus dah gerak ke sana. Means how many K plus to enter? 2 juga. 2K plus akan masuk. So dia balance lah. Bacaan yang kita dapat atas ni, SHE dah tahu 0.00 volt. Bacaan on the voltmeter is positive 0.34 volt. And we want to find the electric potential of copper. Then we are going to use the formula of apa? Apa formula yang kita nak guna tadi? E naught cell equal to E naught cathode minus E naught anode. Who is going to be your E naught cathode? Copper or SHE? Copper, the one that accepts the electron. Okay, so kita position dia copper minus hydrogen. E naught cell kita tadi positive 0.34. We want to find E naught cathode minus with 0.00 volt comes from SHE. And lastly, your E naught cathode is positive 0.34 volt. So this value is positive value. They indicate they want to perform reductions or oxidation. Kalau positif, kurang elektron. Dia akan accept. Reduction lah, ingat balik. Anode always oxidation, cathode always reduction. Ingat yang tu je. Okay, so kalau dekat SRP table, awak rasa dia duduk nombor dekat atas ke bawah kalau positif? Reduction sebab bila positif dia akan favor reduction reaction. Okay, kalau perasan sini kita ada ni, kosong ni, water. Ada kosong. Ni water kosong. Jadi tengok. Okay, so how to read this standard reduction potential? Bacaan ni dia buat pada 35 degree C. Ni adalah bacaan untuk setiap your electron. Kan, kalau kita ada zinc dan copper, kita tahu dah. Zinc negatif 0.36, copper 0.34 volt. Kalau soalan nak minta awak cari, dia akan bagi dah dalam soalan. Awak tak akan diberi this table dalam exam. Dia akan bagi value dah. Tapi untuk kita belajar, nanti saya akan provide awak dengan table. Okay. So you can see we have two values here, positive and negative. And in between them, we have this 0.00 volt. This 0.00 volt comes from the hydrogen electrode, which acts as a reference. Okay? Sebab itulah kita guna SHE tadi nak cari electrode potential. Nak dapatkan semua number-number ni. So, we know when they have less electron, they tend to have positive SRP value. What kind of reactions yang dia akan buat? Reduction or oxidation? Reduction lah. Less electron, more positive value, then reduction. Kalau kita ada more electrons, they will have negative SRP value, means they will perform oxidation or reduction. Oxidation. Okay, now kita nak tentukan satu anode, satu cathode. If we have positive SRP value, means dia akan, kalau negatif SRP value, dia akan jadi negatif terminal. Sebab kita faham, bila negatif, dia banyak elektron. Sebab this is spontaneous reaction, dia yang akan provide the electron, right? So, dia will become anode or cathode. Anode. Dan dia akan jadi cathode. Okay, boleh? So, kita bercakap, anode will always undergo oxidation and only for voltaic cell, they will become the negative terminal. So, they akan perform this reaction. While for cathode, they will always undergo reduction, but only for voltaic cell, they will become positive terminal. Kenapa saya emphasize only for voltaic cell? The negative terminal is oxidation, the positive terminal is the reduction. Because this is spontaneous reaction. In contrast to electrolytic cell, you have non-spontaneous reaction. Maksudnya, the assignment of positive and negative terminal will be the opposite. Okay? Will be the opposite, but then
always remember oxidation for anode, reduction for cathode. Itu kekal, tapi terminal akan berubah. Kenapa berubah? Reaction tak sama. Satu spontaneous ni, satu tak spontaneous. Okay. So example ni basically nak tunjuklah macam mana nak guna. Bila soalan bagi, macam mana kita nak tentukan siapa akan oxidize siapa. Okay, you are given these three species, chlorine, iodine and bromine. Okay, they are all in group 17. And these are the values, positive, positive and positive lah. By right, semua akan perform reduction kan. Tapi macam saya kata, in reaction, tak boleh ada dua-dua reduction. Tak boleh ada dua-dua oxidation. Dia mesti dua-dua berlaku. Tak kisahlah semua adalah positif atau negatif. Okay, so now, initially you have Cl2 and also I2 only. Dia cakap dari soalan. Dia kata, containing Cl and I minus. But then, they ask you to predict what will happen if molecular bromine is added into the solution. That's why we have this bromine. Kalau kita tak masukkan bromine, boleh tak saya tahu siapa yang akan undergo oxidation between these two? Siapa? Iodine. Kenapa pilih iodine? Sebab because the E0 value is more negative than this Cl2 with positive 1.36. Kalau ikutkan, I2 akan undergo oxidation, Cl2 akan undergo reduction. Itu adalah reaction asal. But then kita introduce Br2. Br2 now with a new value of 1.07. So you must take into account of this value untuk tentukan siapa undergo reduction or oxidation. Okay. Kita tahu yang paling negatif akan jadi oxidation, yang positif akan jadi reduction. Okay, tapi bila dia masuk Br2, maksudnya dia nak tahu ability of this Br2 to buat reaction. Br2 now got more positive value than this one, but less negative kat sini. Jadi kita cakap yang Br2 ni has the ability to oxidize I2. Kenapa dia boleh oxidize I2? Sebab value of I2 lebih rendah pada dia. Dia akan undergo oxidation. So this species I2 will become the oxidizing or reducing agent. Kalau dia undergo oxidizing agent, dia buat oxidation, maksudnya dia akan jadi reducing agent. Kalau Br2 dia masuk, dia akan oxidize sebab sekarang Br2 adalah the oxidizing agent. Sebab tu kita kata Br2 will oxidize the I2. Because Br2 got more positive value, they will undergo reduction. In other words, they are the oxidizing agent. As an agent, they will have the ability to oxidize the other species. Make sure the other species to be oxidized should be lower than that of the one that performs reduction. Sekarang awak ada positive reduction. Sepatutnya kalau dia nak oxidize, dia kena yang ambil yang lebih negatif pada dia lah. Okay, kita kata Br2 cannot oxidize Cl minus. Kenapa? Dia lebih positif. Kalau ikutkan, dua-dua akan favor reduction. Both can become the oxidizing agent. How are you going to oxidize the other species yang lebih kuat daripada awak? That's what meant by this statement. Br2 will oxidize I minus because the value is more negative and they are a better reducing agent, oxidizing agent. But then, if we want to compare Br2 and Cl2, Cl2 got far more strength than the Br2. Okay, so kena faham juga oxidation, reducing agent, reduction, oxidizing agent. Siapa agent tu? Itu pun kena tahu. Agent tu adalah the one yang undergo the reaction. Kalau kita kata dia undergo reduction, the oxidizing agent is the Cl2, not the Cl minus. And the other way around. So, lastly kita cakap I2 akan undergo oxidation, Br2 akan undergo reduction. That's what happened when you introduce Br2 into the solution. Okay, last part of this lecture, 3.2. This is the Nernst equation. After knowing all the Voltaic cells, how they work, lagi apa? Macam mana nak cari electron or cell potential, macam mana nak baca SRP table, then kita akan apply dalam Nernst equation. Okay. The other yang kita belajar tadi happens at standard condition. Okay. What if kita tak ada standard condition? Given to you in the question, different concentrations apart from 1 molar. Given to you different concentrations selain 1 molar. kita tak boleh kata dia at standard condition. Kita kena cakap dia at non-standard condition, non-equilibrium condition. That's why we need to know this Nernst equation. Dia kata untuk cari, tak kisahlah dia tak cari concentration ke, nak cari apa, E-cell ke, at non-standard condition. Kita nak guna Nernst equation. Saya nak tahu non-standard, selain 1 atm, selain 1 molar, selain 298 Kelvin. Dia bukanlah semua kena selain. Salah satu tu berbeza, terus non-standard condition. Okay. So this equation, basically kita nak tadi tu standard cell potential untuk standard condition. Tapi sekarang ni Nernst equation at any chosen concentration. This is the formula. Okay, kalau perasan Nernst equation, we have E cell, totally a new variable. We have E naught cell, kita dah jumpa belum tadi? Dah, kita dah jumpa kat sini kan? So somehow, Nernst equation, even though dia berlaku pada non-standard condition, their value will still rely on the standard condition. Maksudnya, dia tak bukannya completely different. They still rely on the standard, tetapi ada sedikit uncertainty. Mungkin dia tak exactly the same as standard. Dia ada kurang, ada lebih. So awak akan perasan, value of E naught cell awak lebih kurang sahaja dengan E cell. Tapi kenapa nak kena guna this equation? Sometimes the questions can ask you about the concentration. In your standard cell potential, do you have any variables that characterize the concentration? Tak ada. So kalau dia minta concentration, confirm guna Nernst equation. Sebab tak ada pun dalam standard cell potential kita ada concentration, kan? Terus guna ni. Okay, asalnya E naught cell minus RT over NF ln product over reactant. How do we know which product to take? How do we know which reactant to take? Okay, first kena tahu dulu, the R is the gas constant in joule per mole per K. Bukan 0.08206. Okay, dia dalam 8.314 joule per mole per K. And then, temperature is 1 Kelvin. Dia depends lah temperature berapa, tapi dalam Kelvin. N is the number of mole yang kita balancekan chemical equation tadi. The net reaction kan. N2 is the number of electrons. And then the F is the Faraday's constant. 1 Faraday equals to 9,500 Coulomb. Okay. So, this is basically the RT over NF and stuff. So, macam mana kita nak tengok lagi this equation? Dia ada cakap juga, at 298 Kelvin, R of 8.314 and 1 Faraday, we know the equation can be modified into this. Usually, awak punya reaction berlaku pada 25 degree C. Bila 25 degree C disebut dekat 25 degree C, awak terus boleh guna this formula. Dah tak perlu dah guna tadi. Yang tadi ni, kalau dia tak bagi tahu lagi berapa temperature. Kalau dia dah cakap at 25 degree C, terus hafal yang ini. 0.0592 over N. Tak ada dah R. Kenapa tak ada R? This 0.0592 comes from the R of 8.314, comes from the temperature of 298 Kelvin, comes from the Faraday's of 96,500 Coulomb. Yang remain adalah number of moles. Because not all electrons and not all reactions will have 2 electrons to be released. Not all reactions will have only 1 electron to be released. This number of electrons will rely on your net equation. Okay, okay, log Q. Now, tadi non, sekarang jadi log. Bila dah tukar, jadi log. Okay, bukan log lagi. Q awak still the reaction quotient, product over reactant. Mana nak tahu product dengan reactant? Tengok dekat net equations awak. On the right hand side will be your product. On your left hand side will be the reactant. Pada net equation. Bukan oxidation, bukan reduction. But the overall equation. And then, where comes this power? X dengan Y. This power comes from your coefficient. This power comes from your coefficient. If you have 2H plus on your product side, means how do you write this? H plus to the power of 2. If you have 4H plus, H plus to the power of 4. Macam tu. Okay. And then, kita ada modification sikit. At equilibrium, the E cell here should be 0. At equilibrium, the E cell should be 0. How do we know they are at equilibrium or not? Dia akan state dalam soalan. So, kita rearrange. Ini sahaja your E naught formula. Kita akan tukar Q jadi K. This K represents rate constant at constant at equilibrium. Kita pernah jumpa kan K before ni? Last time jumpa, chapter 1 jumpa. Okay, tak perlu dah product of reactant. Kalau at equilibrium tak perlu dah product of reactant. Nak cari K sahaja. Okay, is the equilibrium constant? Okay lah. Right. Then the question can also ask you whether this reaction is spontaneous or not spontaneous. Okay, dalam Voltaic cell, walaupun kita tahu dia spontaneous reaction, kita pun boleh tentukan whether they are going to form spontaneous reactions or not. This spontaneity of reaction. They will depend on this value. It's either E not cell ataupun E cell. Depends pada soalan awak stop sampai mana dia nak tanya. Kalau you cari sampai E cell, means your spontaneity of reaction depends on your E cell value. Okay? Kita tahu E cell kita dapat daripada product of reaction kan? Product sepatutnya banyak lah baru kita tahu dapat spontaneous or not. Dia akan favor the reaction. So, for spontaneous reaction, E not cell or your E cell should have value greater than 0. When we say greater than 0, the value should be positive. Whenever you have positive value, they belong to spontaneous reaction. If your E not cell or E cell equal to 0, they are at equilibrium. If they are non-spontaneous reactions, what do you think about the E not cell or E cell value? Less than that of 0, maksudnya negative value. Okay? Right, example, very quickly. You are given cell notation. If the value of cell potential is 1.198 volts, can I know this cell potential, what is the symbol? E not cell or E cell only? E cell only. Okay, bila E cell nak guna Nernst ke tak? Awak ada E cell? Dalam standard electrode potential tu ada tak E cell? Tak ada, confirm tidak cell. Confirm Nernst equation. Okay, itu satu. Baca soalan lagi. Determine the concentrations of H plus solution. Dia ni tak concentration kan? Confirm dia nak cari? Nak guna? Nernst. Okay, satu lagi. Dia nak cari unknown. Walaupun sini 1 molar, dia nak terpedaya. So, kita tak tahu lagi betul ke dia 1 molar. Nak cari concentration, terus go for Nernst equation. Okay. So, first kali sebelum nak buat Nernst equation, dapatkan dulu the net equations, the overall reactions. How do you get these overall reactions? Oxidations dan reductions combined by discarding the number of electrons. Make sure number of electrons is equal, then only you can get the net equation. Everything on the right is product, everything on the left is reactant. So your reaction quotient apart from concentration, dia boleh juga dari pressure. Soalan ni ada tak pressure? Ada. So H2 pun kena masuk dalam awak punya reaction quotient. H2 duduk belah mana? Kiri kan? Duduk kat reactant bawah. So kita akan guna this Nernst equation lah, saya dah buat lah. Okay, H plus kenapa dia duduk belah kanan? Sebab sini. Ni ada AG kan? Oh lupa nak tambah, patutnya kena ada pressure juga sebab ada H2 gas. Ada value, patutnya kena ada pressure kan? Concentration dengan pressure boleh jadi your Q. Depends pada soalan bagi kita. Bye.